All right, ladies and gentlemen, welcome to the RISC-V International booth, and great to see so many people here. My name is Florian. I'm a RISC-V ambassador, but I'm also a sales manager in my part-time job for Endis Technology, a company doing IP, so something which comes in microcontroller units. And today I want to give you some overview about RISC-V and functional safety. What is functional safety? Functional safety is a standard you need if you want to put a microcontroller in a car. You may not need it, but it makes things more safe. So before I'm starting to talk about how RISC-V already can be used in the automotive industry today, I just want to come back why RISC-V is so great. So RISC-V is starting a new age. It is starting with the domain-specific architecture where you can define your own instructions, where you can have hardware accelerators loosely or closely coupled with your CPU and distinguish your own architecture, your own microchip from your competition. But another point in the age we are is also security. Everything is connected to the internet, your washing machine, your car, everything. And people trying to hack it. So you need to make sure that everything is secure. And to make it a little bit more challenging, we are also in the age of agile development. That means we don't have 4, 5, or 6 years for a development anymore. No, it needs to be ready in 1 year, maybe in 2 years, so everything is getting more and more fast and accelerating. And then last but not least, we're in the age of an open instruction set architecture. And that's RISC-V, and that's really where it's becoming cool, because what it makes, it's a contract between the hardware and the software, and it allows you to be more flexible. So the guys from the software can bring more individual new things, the hardware guys can innovate, and all leads to a golden age of CPU microcontroller architecture. Okay, that's why we need RISC-V, because we have challenging times, exciting times. The next point is, where is RISC-V used today? So in the company I'm working for, Endis Technology from Taiwan, we are identifying more or less 5 main pillars. The first pillar is the mobile sector. If you're using a smartphone today and you have a smartphone from Greater China, for example, there is a high chance you already have RISC-V inside. Not as the main processor, but as something like the Bluetooth, the Wi-Fi, touch screen, or maybe the unlocking with your finger screen. That is actually a huge market, and RISC-V is already very strong in it. The next market is in IoT microcontroller units. What is this? That is, for example, a general purpose microcontroller unit, which you can have your own software running on, and you can program it as you want for the application you want. Here RISC-V is gaining more and more traction, which is also a good sign that RISC-V is now mature enough, has a good software ecosystem supporting it, and people really can start using it for industrial controls and other things. Strategically, RISC-V was be driven by the AI sector. So that means everywhere where you have some artificial intelligence, mainly in data centers, customers already using it and making custom ASICs. That means you have a big data center somewhere for one of the big search engines or whatever, and they have accelerator chips inside, leveraging RISC-V, making if you're searching for a picture, if you want to find pictures with dogs or see what's inside, more fast and more power saving. Another pillar for RISC-V is 5G, because RISC-V is a flexible architecture where you can define which instructions, which modules you want to have inside. With 5G, that is helping extremely because of changing algorithm, because of different workloads. You can have one CPU optimized for different workloads in the same chip. So here, for example, if you're working in this field, I recommend you to check Picocom or HQ. They are also around here, and Picocom actually talked about the architecture and why RISC-V is the best for them. They have it on their website. It's a very interesting video if you're in the design of microcontroller units. Last but not least, storage. You all have a laptop maybe like me. Maybe you don't have the cool looking RISC-V sticker on it. I do. But in your laptop, you need to have a storage. And this storage is nowadays already switching to RISC-V. There are several big companies working on it, like Western Digital, for example. but there are also many more companies who are not making it publicly. So if you're buying for example, an industrial SSD, there is a high chance there is already a RISC-V CPU from Andes inside. So that are the main pillars where we see the growth for RISC-V, and I just want to give you some more examples. For example, Picocom I mentioned, that is Open RAN. Open RAN, that is also a kind of new technology. For example, your 4G, 5G network. In the old time, it all came from one vendor. And they provide you everything, from the power supply over the servers, to the antennas, to the amplifiers, everything one guy. With Open RAN, the idea is that you have more an open infrastructure, you can mix different architectures, and you can also have your own software stack on it. And that is accelerated by RISC-V. So in one of these Open RAN chips, for example, there are 32 cores of RISC-V inside. The RISC-V cores come with a floating point unit. It's a 5-stage pipeline, relatively small and compact, but it's made for package handling, so the receiving or transmitting pictures, quite cool and already in use today. The next one is a general purpose microprocessing unit. That one, for example, is Renesas. I highlight you to check them out. They are here in Hall 1, stand 200, something in this direction. And Renesas has made a Linux-capable microprocessing unit with RISC-V inside from Andes. And the cool thing is now that you can buy an off-the-shelf microprocessing unit which is running an industrial-grade Linux, and you can put it in your application. Renesas also has compared it to ARM, so you're seeing here the comparison is to ARM 55, A55, quite nice. And if you want to buy a module for your next project, there are also people who are making modules in Hall 5. All this has shown that RISC-V is really going big. RISC-V is becoming more mainstream. It started with small microcontroller units, but now ranging up to the high-end cores. In the beginning, it was very specific with artificial intelligence, but now we are ranging to general purpose microcontroller units, microprocessor units, where people can do really what they want and how they want it. And how do you see that RISC-V is going big? Well, it's the industry adoption. So more and more adoption is coming, and two important points from my point of view. The first one is the industrial adoption, where you really got RISC-V used in the industrial projects. And the last one is automotive. So with the automotive adoption, you are seeing now RISC-V starting to being deployed into cars. And that is actually what I want to talk today about, the automotive and how RISC-V is adapted there. Before I'm going to the automotive, 2 more pages, please bear with me. One is the roadmap Andes is offering. I thought it might be interesting to give you an overview what you can buy. So we have different IPs, starting with a very small microcontroller unit, then the 25 series, a little bit more powerful. And what you see is that this IP can scale. So on the left side, you have a embedded control unit, and if you're going to the right side, more features added like a DSP extension, that's the RISC-V RVP extension, or the RISC-V vector extension, adding to MMU for operating systems, and in the end also multiprocessor with L1 and I/O coherence and L2 cache available. So that means if you make your own microcontroller, microprocessor, your ASIC, you have a whole spectrum where you can select CPUs, most of them available in 32-bit or 64-bit, and there will be something for everyone. The second important point about RISC-V is you not only need to have the core, the IP, you also need to have people supporting it, an ecosystem. So here, for example, Andes as a commercial supplier, we are working with a lot of partners to make sure if customers licensing our core, everything is working out of the box. Different regions, for example, Andes, we make the core, and then our customers or you want to debug it. So we are working with leading companies like Imperas, who is here, Segar, IR Systems, or Lauterbach. They have our IPs, they know how it works, they're integrating it in their tools, and make sure when you get our IP, everything works out of the box. The same goes for security. Like I mentioned, today security becomes more and more important. Everything is connected to the internet all the time, so you need to have good partners. And here, for example, Silex Inside, they have a root of trust, they have encryption, and they are using inside Andis RISC-V CPU. So you're licensing an Andis CPU, you need some security, you get Silex Inside, suddenly you have 2 CPU from Andis. You also have other partners, of course, so Tsaya is also here, they make software. The guys from Codeplay are over here. What I want to show with this slide is that you need an ecosystem, and with RISC-V, some people concerned there is no ecosystem. No, it's not true. You have the biggest possible ecosystem, everything is already pre-integrated and make your life more easier. Okay, that was some warm-up. Now let's talk about functional safety. The question I have, is RISC-V ready for functional safety? You bet, it is. So what does it mean when I say RISC-V for functional safety, and how do you prove it's ready? The first thing is, for example, Andis, we got certified for ISO 26262. Most of you know that's the standard in automotive, how you prove you're certified. And here Andis as a company, we got certified for the processes up to ASIL-D. That means our R&D engineers can certify the process up to ASIL-D, make our own course. The second step is now the company is certified, the guys from TÜV Süd checked that everything is going well, now we need to make a product. So we started with the N25, remember that was the core who is used also in 5G, for example, 32 cores, and we made an ASIL-B version of it. So the engineering version is ready, and it's now on the table from TÜV Süd to get it certified. So we are not only making a ready core with safety manual and all this stuff and then sell it to our customer. No, we go one step further and we also get it certified by TÜV Süd. There are also more cores in work, and we will have some more announcements by end of this year. However, with this N25F, which we have already for automotive, we have already some first customers, and I want to share with you a little bit the application and the usage of RISC-V today. The first application is a car terminal. Maybe some of you have noticed, I haven't, I have an old car, but I came to Germany, I rented a car, and everything is digital. You have a screen in your car showing you the speed, having nice animations, and it's really cool if you're driving it. But why do you need functional safety? Because it also has important information like speed, or if your engine is too hot, and you need to make sure that it's displayed in the correct way. So a functional safety ready core makes sure that if there is any problem, you will get highlighted of this. The next one is a low power radar. Some potential applications for this is, for example, when you're driving, the radar is detecting if you're tired or something like this. It can alert you. The radar also could check if you have your hands on the wheel, something like this. Or the radar, when you're locking your car and you're walking away, can check if there is something inside. Maybe you forgot your dog, maybe you forgot your husband or your fiancé. So the radar can check this and can send you an alarm. Quite cool, I think. The last one is, not the last one, but the next one would be ECU. So the car is becoming more and more electrical. There are more and more high performance CPUs inside, and they need to communicate. And that can be done by RISC-V. We are seeing this change actually happening right now, and that's why Andis is also pushing for this functional safety, because more companies adopting RISC-V, and what we are seeing right now, it's in the subsystem. Big cores will also come. I think it will take a little bit, but coming. And last but not least, touchscreen. You're wondering, why should there be functional safety in a touchscreen? Well, if you look on the latest cars, for example Tesla, you have a very big screen inside and you can do a lot of functions. Imagine if your touch is not working. So for example, you want to unlock the brakes, or you want to start the engine with a touch screen, or you want to stop the engine and it's not working. That would be a potential hazard for you as the driver. So the touch screens in these large displays need to be functional safe. That means they cannot break down, or if anything breaks down, make sure that the whole system stops without giving any trouble to the people. All right, there are some use cases. I want to go a little bit into the core to show you what Andis is providing. So that's the core I mentioned before, the N25F-SE. SE stands for Security Enhanced, so that's our name for the functional safety. What the core is, it's a 5-stage pipeline, single issue, 32-bit core, and it's highly configurable. If you're looking here on the diagram, you have branch prediction, you have multiplier, divider, you all can enable them, take them out. That means you can adjust the performance of your core to your daily needs. For functional safety, you also have the ECC code inside for both memory and instructions, of course. We are leveraging the physical memory protection, which is a great part of RISC-V. And then last but not least, Andes also brings some additional thing. It's Codance. It helps you to make your code even more smaller than what RISC-V is doing. This core is available now. You can license it, and the official certification will be ready in the following weeks. Functional safety is great, but you also need to have the software, which brings us back to ecosystem. So here, Andes, we are again partnering up. We go to our partners, talk with them, getting them engaged, which will also help later other people who are offering functional safety with RISC-V. The first partner we worked very closely with is IR System, a Swedish company. They make great compilers, great debugging tools, and they have a compiler ready for functional safety in automotive, up to ASIL-D. So if you're buying a core from Andes nowadays, we will support you with IR systems together so that you can get your software running and no problems. In the meantime, we are also pushing for a wider partner ecosystem. So for example, we work with Siemens on their V-Star, which is an AUTOSAR implementation. We are working with Wittgenstein to get safe RTOS running on our cores. It is actually already running. We are still doing some regression tests. Green Hills, we are in contact. There are a lot of names, also Microsoft, big ones. So the main message here is functional safety is good, RISC-V is good, but you need to have an ecosystem to support this, to bring everything together. And remember what we said in the beginning? Security is also very important. So also for security, we are working on this. So you have the Andes RISC-V core below, and you have different flavors of secure monitors. For example, SIA is also here in the halls, Hex5 and Virtual Open System. And what they are doing, they are separating your tasks. So if you have one task, for example, driving the display, and another task is communicating with other parts in the microcontroller, you should separate them. So in one case, one part is crashing, it's not taking down all the other parts. And that is what the security together with our partners doing. Of course, we also bring in some own IP. If you are working in RISC-V, you may have heard about the IOPMP. It's some kind of physical memory protection, which is now also under discussion for an official spec. And this is actually driving this heavily together with other partners. For automotive, the safety and security and reliability are the big things. So here Andes is working closely with the customer. We're following the specification, we have integrated, and now we are making it happen so that our customers get a safe, secure, and reliable core. The goal is that we are protecting both systematic and random hardware failures. And the built-in hardware safety mechanism, which we are building in our core on top, should make your life more easier and allow you a faster time to market. So the value Andes is delivering is actually, we are focusing on customer success first. So for us, it's important that you're successful, We are pushing this ecosystem. The highest value, you get scalable cores. That means you license one core, but you can adjust the performance from low performance up to high performance. So that means you have one license fee, but you have different levels of performance as you need it. And then you get the lowest risk. We will offer 20 years longevity as in planning. It's a market-proving solution. So in this case, we took an existing core, which is already licensed multiple times. So we are talking over 50 commercial consumer licenses. And this core is now also available for functional safety. So from my perspective, to kind of close this talk, because I'm running out of time, I think functional safety is ready for RISC-V. If you're working on microcontrollers for this, make sure that you're talking with Andis today. Our booth is here on the left side, and we are being happy to talk with you, see more coming. Thank you very much for your time. Do you have any questions? I think I have time for 1 or 2 questions. No questions, that's a good sign. That means I could answer everything. If you still have questions and you're maybe shy like me, I'm normally very shy, except I'm on the front stage. You find me on the left side, you find my colleagues there. Feel free to ask us about RISC-V. And with this, thank you very much and make sure you contact us.